If space is curved, light curves with it. So if a curved piece of glass can make a...
Some physical objects are simple, but have profound applications. Take lenses, for example. The magnifying glass that you use to read tiny text is a lens. If you casually observe a lens, you may say that in a way, it distorts the view of things behind it. In this video, we're going to learn about a very special kind of lens. A lens that is helping us to discover new galaxies and see what is otherwise unseeable in the universe. It is a lens born out from one of the fundamental forces of nature, gravity. Although our understanding of gravity is limited, we can certainly say that it's a pretty amazing force. Interestingly, the supercool force of gravity also has an eccentric bag of tricks up its sleeve, one of which is its ability to act as a lens. Gravitational lensing occurs when a huge amount of matter, like a star, galaxy, or a cluster of galaxies, creates a powerful gravitational field around it, strong enough to bend light coming from distant galaxies behind them. Gravitational lensing tends to magnify distant sources that are otherwise blocked by the galaxies in front of them, although the view is often distorted.
Just like a magnifying glass. The closer the light gets to the black hole's edge. Hi, today, we are going to explore an incredible phenomenon you may have seen in a simulation, how light behaves when a black hole comes near the sun. In this video, we'll explain why the sun appears to move in a semicircular path, stretch, and enlarge when viewed behind a black hole. What you are witnessing is called gravitational lensing. This happens when the powerful gravity of a black hole bends the path of light passing near it. Einstein's theory of general relativity predicts this effect, where massive objects warp the fabric of space-time, causing light to follow a curved path. In the simulation, as the black hole moves or the observer changes position, the sun's light bends differently. This bending creates distortions that make the sun look like it's moving in a semicircular path. Sometimes, if the sun is perfectly aligned behind the black hole, it forms a full halo of light called an Einstein ring. You might also notice the sun enlarging and shrinking. This happens because the black hole's gravitational field magnifies the sun's light, just like a magnifying glass. The closer the light gets to the black hole's edge, or event horizon, the more it bends and the more magnified the sun appears. This phenomenon isn't just a simulation concept, it's real and used in astronomy. Gravitational lensing allows scientists to observe distant galaxies, detect hidden black holes, and even study dark matter. So, the next time you see light bending around a black hole in a simulation, remember, it's not just stunning, it's physics at its finest.
Where the black hole acts like a magnifying glass, revealing objects far behind it. Black holes aren't just cosmic vacuums, they're masters of light-bending magic. Let's talk about gravitational lensing. Here's how it works. Black holes have extremely strong gravity, so strong that it warps the very fabric of space-time. When light from distant stars passes near a black hole, it doesn't travel in a straight line, it bends. This bending can create a phenomenon called an Einstein ring, where the black hole acts like a magnifying glass, revealing objects far behind it that would otherwise be invisible. Thanks to gravitational lensing, astronomers can study the universe's hidden corners, distant galaxies, dark matter, and even the early universe itself. Black holes aren't just destroyers, they're cosmic windows, giving us a new way to see the universe.